Good afternoon, everyone, and welcome again. Thank you for your patience. We are thrilled to have you with us today as we deep dive into the most important topic in cloud computing, that is how to optimize cost while maintaining high performance in Kubernetes and serverless architecture. Today, you will gain actionable insights to help you streamline your cloud infrastructure and maximize efficiency. But before getting started, a couple of quick reminders. Number one, that this session will be recorded for the future references. Second, in between the session, if you have any questions, please drop them into the chat and we will address them in the Q&A at the end. So now please allow me to introduce our speaker for today, that is Mr. Ashish Ingle. We are excited to have him here and he can share his expertise with us. So, Mr. Ashish, the floor is all yours. Thank you.
Hey, hi everyone. Thank you, Richa, for giving me this opportunity. So, yeah, let's start. Hello, everyone, and thank you for joining today's webinar on unlocking cloud savings with special focus on Kubernetes and serverless architecture. This topic may seem very general, and you might be familiar with Kubernetes or serverless computing. However, our small ignorance, like mine also, with these cost control practices can significantly impacting the entire organizations and even at the industry at large. Regarding to that, we will explore some interesting facts also that will definitely be an eye-opener for all of us. I'm sure you will walk away with a new insight and that can make a real difference to your organization. Let me introduce myself. As you can see, my name is Ashish Ingre. I am a senior cloud DevOps engineer with expertise in multiple cloud platforms. I help clients optimize, build, and automate their cloud infrastructure. And if in my personal time, I love traveling, driving, and spending time with my family. All right, let's take a quick look at what we'll be covering today. First, we'll start with a brief introduction to set the stage and give you an idea of what's coming up in this session. Then we'll have a look at the global trends surrounding the adoption of Kubernetes and serverless computing. We'll explore why more organizations are turning to this technology. Next, we'll dive into crucial topic of how millions of dollars currently we are wasting on Kubernetes resources and its key reasons. After that, we'll focus on cost optimization strategies for Kubernetes, covering right sizing best practices and tools that can help us to reduce that unnecessary spendings. Then we'll talk about the same, but for the serverless infrastructure. And then we'll see some of the important key takeaways of this session. And we'll finally open the floor for your doubts and questions. Um, so now, with this introduction, let me set the stage for this session. In a cloud-native landscape, scalability and flexibility are essential for any business success, right? So, for example, applications like Hotstar, especially during high traffic events like India versus Pakistan match, or a recent example like finals of a Champions Trophy. Generally, these events experience massive traffic spikes. So, by leveraging Kubernetes and serverless technologies, they are able to dynamically scale their infrastructures, able to handle millions of successful transactions without any disruptions. These technologies offer incredible scalability and flexibility, alongside many other benefits that drive their business growth. However, while the ability to scale easily is a huge advantage, it can also lead to unexpected challenges. The same scalability that benefits us on one hand, if it's not carefully managed, can become a cause of overspending on the other hand, especially when companies fail to monitor usage properly. In this webinar, we'll dive into some best practices for cost optimization in Kubernetes and serverless environments. We'll explore the strategies to maximize the efficiency, ensure high performance, and prevent the over-provisioning. By applying these best practices, businesses can control their cost while enhancing operational efficiency in their cloud infrastructure. In the next part of this talk, we'll dive into some global trends of adoption of Kubernetes and serverless. It will show that how massively adoption of these technologies are increasing. So let's talk about some trends. What do you think? What are the adoption trends of Kubernetes and serverless show? Any case? Some of you might say it's on a higher side. Yeah. But are you aware that its growth rate of these technologies? Okay. Maybe some of us have an idea, but let me try to explain this in another way. Even if you haven't had the chance to go through some of these articles or posts about these trends, just by casually looking at the job description of DevOps or cloud related positions, you will see the clear pattern. Nearly all of them now require at least some level of a Kubernetes expertise. In fact, here at CloudTechner, we are hiring for multiple positions. And for that too, Kubernetes and serverless skills are prerequisite. These indicators clearly shows that industries are increasingly leaning toward this technology. Moving on to trends, let me show that according to the CNCP 2023 survey, around 80% of organizations are now using Kubernetes in their production environment. Actually, it's notably increased from 70% in 2021. This adoption is even higher in larger companies with 1,000 or more employees. Looking ahead, this adoption is expected to grow even more, reaching to 90% by 2027, especially in managed Kubernetes spaces. Now, on serverless side, it's also growing fast. Around 25 to 30% of the companies are using serverless solutions like AWS Lambda, Azure Function, and GCP's function also. We generally use this for things like event-driven applications and microservices. This number is also expected to jump 45 to 50% by 2027. What's interesting is that both of these technologies, Kubernetes and serverless, are likely to coexist in many companies, creating much more hybrid IT environment. Looking ahead, Kubernetes market is set to grow nearly a 9.7 billion by 2031. And if we see from the budget perspective, in cloud native setups, 30 to 40% of the IT budget could go towards these technologies. This is exactly why cost optimization in this area is matters so much. With such a significant investment going in Kubernetes and serverless technology, we need to make sure that how we can use them efficiently so that it will significantly reduce our overall cost. Okay, now we quickly go through some of the key factors behind this increasing adoption of a Kubernetes and serverless. First one is obviously scalability and flexibility. Both Kubernetes and serverless are really good at the scaling. They automatically adjust based on the request they get. Second one is the increased security and isolation. Kubernetes offers strong features like role-based access and network policies and many more like this. Next one is the event-driven architecture, especially for its serverless. It's ideal for when want to be architect some API call related or some file upload basic application. So in that case, event-driven architecture is the best. This makes it perfect for real-time tasks like processing chatbot messages and handling user request in a flash. The next one is the Kubernetes, now in the cloud agnostic. This means you are not locked into any one provider. It allows you to run application across multiple cloud environments, giving you more flexibility and reducing the risk of vendor locking. Next one is the high availability and fault tolerance. Both Kubernetes and serverless ensures high availability. Kubernetes automatically restart or move pods if they go down, while serverless functions are designed to be a high resilient. And last one is the effortless management. Most of these operational tasks in both Kubernetes and serverless like scaling, load balancing, they handles automatically, helps in significantly reducing this management overhead. These factors make the Kubernetes and serverless powerful solution for modern, scalable, resilient application architecture like Hotstar or Netflix, right? Yeah. Moving to the next slide. Yeah. But still, millions of dollars currently we are wasting on Kubernetes and serverless resources. You might be wondering or questioning this statement, especially after we just discussed some of the great features of Kubernetes and serverless technology. But it's true. Despite their incredible capabilities, the truth is that still so many companies are wasting on millions of dollars on Kubernetes and serverless resources. Let's see in the next slide how much and where we are losing. What do you think? How much we are losing annually? Any guess? All right. Let's break it down and we'll look the resource one by one. As you can see, 80% of the memory we configure in Kubernetes and serverless environments goes completely unused. On top of that, 59% of the containers don't even have the CPU limit set, and 49% are the missing memory limits as well. What's even more concerning is that 69% of the CPU resources are going to waste. When we add up all these inefficiencies, which leads around 30% of the organizations need to right size their containers and functions to boost their efficiency. If we just focus on companies with around 1000 plus nodes, these wasted resources could cost them up to 10 million a year. So this is a massive loss. Resources that could be a better invested in more productive initiatives. That's why we hosting this webinar to raise the awareness among the tech professionals and to focus on improving the cost optimization. Moving to the next slide, we can discuss here about the key reasons behind this inefficiency and wastage in Kubernetes serverless. The first one is obviously the lack of visibility. Many organizations simply don't have the right insight into how their resources are being used. Without proper visibility into the resource consumption, it's nearly impossible to allocate and resize resources effectively. This lack of oversight can lead to a wasted resources and unnecessary cost. Next one is urge to scale quickly. In these days, configuring scaling in Kubernetes and serverless is super easy. So most of us set it up without much analysis. As a result, we meet the demand, but on the other side, we lost a lot of due to the unjustified allocation. Another big issue is that lack of Kubernetes knowledge. Kubernetes is a powerful tool, but without proper expertise, organizations miss out on that optimizing CPU and memory limits, which can lead to inefficient use of resources. The next one is the lack of proper capacity planning. It's another major issue. When you don't accurately forecast your resource needs, you often end up with the over-provisioning. Final one is the multi-tenant scaling. In environments where multiple tenants share the same resources, it's easy to resource to get misdistributed, causing some container to get more than necessary while others are starved for the resources. So let's move towards on our main agenda of this webinar, how we can optimize the cost in Kubernetes without affecting its efficiency. Before diving into the best practices, we should first identify the key areas where that need focus attention. These are just like a cost drivers in Kubernetes. The first one I have identified the area is the compute resources. These are nothing but the cost of virtual machine, CPU, and memory that we are using. Second one is the data transfer cost. Every time data moves between your nodes or across the region, it's add up that extra cost. Third one is the networking. Network traffic, load balancer, and communication between clusters. There is also extra cost depends upon whether that communication is in a private or public network. The goal here is to understand these areas and find the ways to optimize them so that we are not paying more than what we need to do. Now in this slide, we understand that from where that extra cost is coming and adding up. So let's move to remedies, or we can say the practical steps for optimizing the cost effectively. First one is that managing resource request and limit. I'm sure you are all familiar with the Kubernetes. In Kubernetes, we define CPU and memory's request in our container manifest file, right? This request ensures that our pods are scheduled properly and making sure that they get the resources which require them for the to run efficiently. On the other hand, limits prevent the containers from consuming more resources than necessary, which helps to avoid overuse and keep things under control. One key thing to keep in mind here is to avoid over-provisioning. We don't want to set our resource request too high, as that can lead to a wasted resources. To configure right request and limits, I want to suggest one open source tool. Its name is Cube Resource Report. This open source tool provides detailed resource usage report for Kubernetes cluster. It helps us to visualize the resource consumption and enabling us to set more accurate requests and limits. Let's move to the second point, use efficient container images. We can optimize the container images to reducing the cost in Kubernetes by just using smaller container images like Alpine or Distroles. These images are lightweight and help us to save on storage and compute resources as well. You can also use the multi-stage build to separate the build process from the final image, and it helps us to keep the things lean. And also don't forget to regularly clean up that unused images to save on storing cost of these images. Next one is the cluster autoscaler. It's an amazing functionality that automatically adjusts the number of nodes in your Kubernetes cluster depending on the demand. For instance, if there is a spike in demand, the cluster autoscaler will add more nodes. And if demand drops, it will also scale down the nodes. This way, we ensure that we are not paying for idle resources, which is one of the easiest way to cut down on that extra cost. We can also enable scale to zero functionality for environments like dev and test clusters. We generally don't run all the time. It's great to enable that cluster to scale down to zero when it's not needed. This is super useful for temporary workloads. Ensure that we aren't paying for clusters running 24 by 7 when they are only needed for short periods. Fourth one is, and the most common one is the monitor and analyze the resource usage. Let's break this down into the key areas. First one is the monitoring resource consumption. So to keep an eye on how much our workloads are using, we can turn to tools like Prometheus and Grafana. These are great for tracking key metrics like CPU and memory usages across our cluster. On top of that, we can leverage cloud-specific monitoring tools like AWS CloudWatch or Azure Monitor. These services help us dig deep into the performance metrics and track a resource consumption over a time, and helping us that spot that inefficiency before they become problem. The next part of this point is that cost monitoring and allocation. We can use cost allocation tags. By tagging our resources based on the teams or projects or environment, we can easily track the usage of and spending across different parts of the organization. For example, we could tag the resources by simply based on the environment. Let's take example development, testing, and production. So we can just see by filtering based on the tags in which environment costs are accumulating, and later adjust that accordingly. Some of the cloud native monitoring services can also allow us to filter this cost based on the namespaces too. So it helps us to dig deep into the understand that costing pattern based on the namespaces also. Not forget to use the auto scaling effectively. I want to highlight here that we previously discussed cluster autoscaler. Okay? Here I am referring to the pod autoscaling. Tools like horizontal pod autoscaler can automatically adjust the number of pod replicas on resources based on the resource usage. For example, if CPU usage spikes during a high traffic event, HPA will scale up the number of pods to handle that increased load. And then it also scales down when traffic decreases. It really helping out to optimize both the cost and performance same time. Moving to our next point, that is the pricing model. It's a crucial to compare the different pricing models available in the your cloud provider. to optimize the cost. Generally, in all cloud platforms, you will find three main pricing models: uh, spot instances, reserve plans, and saving plans. Let's quickly dive into each of them. The first one is the spot instances. Spot instances are a great way to save money, especially if your workload are flexible. These instances are much cheaper than regular one, but the catch is here that they can be interrupted at any time. So they are perfect for the tasks that can tolerate interruptions like batch processing or background tasks. The second one is the reserve plan. The reserve plan it offers a significant discount, nearly a 72%. But for that, we need to commit for 1 to 3 years. This is ideal for businesses with a stable and predictable workload. However, keep in mind that once you commit to a compute resource, you can't change its type or region. This model is most feasible when your workload is consistent and predictable. The third option is the Azure saving plan. This plan is a great choice compared to the reserve plan, especially when you consider flexibility. With Azure saving plan, you can change the region or compute type without any penalties. Plus, you will get the 55% of discount on regular rate. So it's a solid mix of the flexibility and saving. If you ask me, I would definitely suggest you Azure saving plan, as it strikes the perfect balance between the saving and flexibility. Let me share one example. Suppose you are using a compute resource which is costing you a $720 per month. And if you switch to an Azure saving plan, from starting next month only, you will receiving 55% of the discount, bringing you your monthly cost down to just $320. That's a significant saving of $400. So it's a huge amount, right? $400. Next one is the right sizing node. It's important to select the right node size based on the specific nodes of our workload. We shouldn't be running larger or more expensive instances than what we actually need. If we pick the right instance, it will help us to avoiding and paying for more resources than we are using, which reduces unnecessary cost. The next one is the log storage. Especially when Kubernetes is a part of an infrastructure, it generates huge amount of log data over a time. This includes logs for cluster activities, application events, and metrics. Storing these excessive logs not only add that extra storage cost, but also slows down the queries and increases the resource usage. To optimize this cost, we must focus on reducing log volume and storing only the necessary data. This can really help us to cut down on the storage expenses and mitigate the security compliance risk, especially in regulated industries. Now, let's move on to the optimized network solution. When it comes to the network traffic, cross-region traffic tends to incur a much higher data transport cost compared to the traffic within the same region. So it's always a good practice to keep the traffic within a single region whenever possible, particularly for inter-service communication. Additionally, we can use private link or VNet integration to keep the network traffic within the same VNet. This integration helps to reduce the egress cost by preventing traffic from flowing through the public internet. This can lead to significant saving in data transfer cost as data no longer need to traverse the public network. Last one is the managed Kubernetes service like EKS, GKE, AKS. They simply cluster management by the automating tasks like scaling and security patches. These services not only save huge time but also reduces the risk of vulnerabilities and offer additional features like integrated monitoring and cloud native service integrations. While self-managed clusters may seem cheaper initially, but the time and effort required for management can make the managed services most cost-effective in the long run. So it's always important to compare both the models to find the best option for your needs and budget. Now that we have discussed some of the best practices for cost optimization, which are simple and effective, I understand that implementing them can be sometimes be a challenging, right? To help you that, I would like to suggest an open source tool that is the Carpenter. Carpenter is the Kubernetes autoscaler that automatically provision and scale compute resources based on workload requirement. It optimizes the cost by selecting the most cost efficient instance type. It uses the spot or saving plan instances when those are available, and also right size the nodes based on the actual usage. It also manages the node lifecycle by terminating unused resources. It ensures that you only pay for what you need. It was initially designed for AWS, but now Carpenter is also extensible to other cloud providers. After understanding these best practices of Kubernetes cost optimization, let's move towards our second part of the webinar, how we can optimize the cost in serverless. Again, before diving into these best practices, we should first identify the key areas that need to be focused attention. Let's just quickly go through the key factors that drive the cost. First one is the compute time. In another word, we can say the execution time. The longer our function runs, the more we need to pay. It's important for us to optimize the execution time for our function. Second one is the memory allocation. In serverless environment, we pay for the memory allocated to our function. If our function is allocated too much memory, we are paying for more than we need. Number of requests. Serverless functions are typically built based on the number of requests made. So reducing unnecessary invocations can significantly cut down on that extra cost. Data transfer cost. Transferring data between function or cross services can add up that extra cost. So minimizing data transfer by optimizing how data can be handled and transferred can help lower these transfer costs. Fifth one is the storage and state management cost. Serverless functions often need to store a data or manage that state. The cost of storage and state management can become a significant over time because of this. So using the right storage solution and managing the state effectively is a key for us to reduce that cost in serverless environment. So by understanding these cost drivers, which we discuss in this slide, it helps us to analyze the usage pattern and we can make the smarter decision and optimize the cost in serverless environment. Let's dive into some important strategies for optimizing the cost when working with the serverless functions. First one is the simple and effective way to optimize the cost is memory allocation. We generally charge based on how much memory we use and how long the function runs. If we allocate too little memory, it runs slower, which costs more. So by allocating too much memory, it just wasted money. So the key here is to find that sweet spot where the function runs smoothly without overspending. On the other hand, optimizing the function execution time is also crucial. A slower function means higher cost. So it's important to clean up our code and cut down on unnecessary operations, optimize the database query, and avoid waiting on external services. In short, we can say faster function is equal to lower cost. To help in this configuration, there are tools like AWS Lambda, Power Tuning, which allow us to experiment with different memory configurations and analyze their impact on both the cost and performance. I definitely recommend all of you to check out on this tool. At least take a look. You will see the value, right? We can use this insight to find the perfect memory allocation that keeps us cost low while maintaining the performance. Second one is the cold start. It's nothing but the time it takes to initialize the new instance of the function. A cold start can increase the latency, so we should aim to minimize that cold start time. One way to do this is by avoiding the frequent invocations. Another strategy is to implement warm-up techniques. We can periodically invoke our function to keep them warm. So it reduces the initialization delay. Tools like AWS Lambda Warmer can automate this process, which ensures that instances stay ready for the use. Next one is that function timeout and concurrency control. Setting an appropriate timeout is a crucial to prevent the function from running longer than necessary, which can quickly escalate the cost. By ensuring our functions have a reasonable timeout, we can avoid unnecessary expenses. Let me share an example from my past client experience. They didn't set a timeout for their function, And due to some unnecessary loops, the function would often run for few extra minutes, which was leading to a significant additional cost. During some troubleshooting, we noticed that issue, and after analyzing the logs, we realized that simply setting a timeout could save the thousands of rupees per month. So, and if we talk about the concurrency, concurrency refers to how many instances of a function can run simultaneously. If our function doesn't handle concurrent requests properly, it can lead to an increased cost or performance issues. By configuring concurrency, it helps out in avoiding overwhelming our resources and incurring extra charges. In some cases, we can also limit the concurrency to a better match the scale of our workload. Next one is the optimizing the dependency. We should also focus on optimizing the dependencies. Larger deployment packages can also slow down the initialization time and increase the memory usage. So by minimizing unnecessary dependencies in our code, we can reduce the size of the functions package, which can help us with the faster startup time and lower memory consumption. In this scenario, we can also take advantage of Lambda layer or Azure function extension to store libraries and other components separately. This keeps our main function code lightweight and can reduce both the code start time and overall memory usage. Additionally, tools like AWS X-Ray or Azure Application Insight helps us to trace the request from start to finish. These services provide a valuable insight into the performance issues, allowing us to optimize our function further and improve that efficiency. Last one is the saving plan. It's the last but not the least, right? So using saving plan can make a huge difference here also. Just like we discussed in the Kubernetes section, saving plan can be a game changer for the serverless functions too. By committing to a consistent level of usage, we can unlock up to 30% of the our function cost. So this is a perfect for workloads that are predictable and run frequently. Okay, now let me go through the tools which we just discussed so far, just to reinforce that what we covered, and this way it will stay fresh in our minds. First one is the Kube resource report. This gives us a deep dive into the Kubernetes resource usages, helping us to fine tune our cluster performance and while keeping the cost in check. Second one is the saving plan. AWS saving plan lets us take the advantage of a flexibility in the pricing for long-term workload, which means we can save a big on compute cost across multiple services. Third one is, and most important one is the Carpenter. This is an open source Kubernetes autoscaler that automatically provision the right amount of compute resources, boosting our cluster's efficiency and cutting down on unnecessary cost. Next one is the AWS Lambda power tuning. With this tool, we can fine tune the memory and power setting of our AWS Lambda function to improve both performance and cost efficiency. Fifth one is the AWS Warmer. AWS Warmer helps to reduce the cold start latency for any function and ensure faster, smoother, and response time when the function is triggered. Next one is the AWS X-Ray. AWS X-Ray is it can help us to trace the request from start to finish. These services provides valuable insight into the performance issues and allowing us to optimize our functions further and improve the efficiency. And last one is the Azure App Insight. Azure App Insight offers more powerful monitoring capability, giving us good deep insight into our Kubernetes and serverless performance. It's a user interaction and usage pattern, so we can make the data-driven improvements, right? So by understanding these tools and how they work, we'll be able to optimize our cloud environments effectively, and we'll get the most out of our infrastructure. So after understanding all these points, let's now summarize with the key takeaways. Kubernetes and serverless technologies are becoming more popular, giving businesses more flexibility and scalability. But surprisingly, many companies are still wasting money. About 69% of the resources don't have just limit set. So leading to these inefficiencies and wasted resources. We saw it during our loss where we mentioned in that slide, right? This usually happens because of the business don't have the clear visibility into how much they are actually using and also don't know how to configure things properly. However, the good news is that by applying the right sizing practices, which we discuss in this our webinar, large companies could save millions a year, right? These savings come from cutting down on unnecessary resources, improving efficiency, and optimizing the cost in infrastructure. So by better matching resources to actual need, companies can boost their performance and cut down on that wasted cost. So I hope you enjoy this session. The floor is now open for any questions or any doubts if you have.
Ashish, if you allow, I would like to add a couple of points in your presentation. It was a great, first of all. But before, like you mentioned about right sizing nodes, okay, if we go one step back and choose the, let's say there are three CPU architecture in market. One is Intel, AMD, and ARM, where Intel is being the most costlier. Being from a CPU architecture, AMD and Intel ones is 99%. The CPU architecture is same, but in terms of a cost, AMD is a 30 to 40% cheaper than Intel. So if you talk about cost, that is the one. And ARM, which has a x86 architecture, but if you can manage to generate your Docker files or container images in a multi-architecture framework, you can easily reduce your cost by a large part. And especially on a non-production environment where you don't need reliability of your cluster that much, but it's still important. So if there is a cost matters, then the reliability versus cost, where I would say basically a right designing your dedicated instances and a spot instances. Those are the 2 points which I would like to add from my side. But thank you, it was a great presentation.
Yeah, thank you, Nishant, for adding that. And those points are value points, right? I would like to implement those while any in my future. If I want to implement that in our infrastructure, it's good to.
Hi, Ashish. I have a question.
Yeah.
So, Ashish, you talked about the open source tool, Cube Resource Report. So, is that require any agent installation on cluster?
Uh, Actually, Rohit, no, it's not required any agent on the any cluster. Just it required the Prometheus access, as it uses the Prometheus metrics for its reference, and by looking into that matrix, it find out for ourselves that uh, this pod require this much limit and this much memory and CPU limits. So based on the Prometheus data, it suggests us so it don't require to install the agents on particular Kubernetes cluster.
Okay, thank you.
Yeah.
Hi, Ashish. So,
Yeah.
how do you handle database queries and service calls within your serverless function to minimize delays and keep cost low?
Okay. So see, to optimize the database connections in serverless functions, we use the connection pooling, right? As some serverless environment supports a persistent database connection, so it helps to reduce that overhead of the opening new connection. Additionally, we can also use the optimize the queries by avoiding unnecessary queries and utilizing the indexing so that it speeds up the data retrieval. Uh, Regarding to this, in my last project, we implemented these things, and we also use the what we can say the private endpoints while connecting to the database to the our serverless architectures. So it helps us to keep that traffic in a inside the we can say inside the network, and it helps us to reduce that data transfer cost. Yeah.
Okay.
Okay. Anyone? Anyone has any doubts or question?
Yeah, one question from my side, how do you handle changes in workload demand while using Azure plans, especially if you need to adjust a source or change region?
Uh, See, actually, this is the problem with the reserve plan. Means we can have much flexibility this in the saving plan. This flexibility we didn't means we don't get generally in terms of reserve plan. Once we choose the reserve plan, you can't change its region or its the CPU type. We need to pay some extra money for that change. So it's always better to choose the saving plan. It also provides us the 55% of the discount, and in future, if you want to change its type or region, you can change that by means if you choose the saving plan. But this flexibility is not available in the reserve plan.
Okay, okay,
Yeah.
yeah, thanks.
All right, any more questions? All right, thank you so much, Ashish. Today we did had some fantastic question, but we do have the time constraint and we will need to wrap up the Q&A here. But if you still have some question, don't worry. You can reach out to us via email and we would be more than happy to assist you. I'll post our contact details into the chat. Just give me a minute. Yes, here we go. All right, so before we wrap up, I'm sure everyone has gained a valuable takeaways on optimizing the cost in both Kubernetes and serverless architecture. So firstly, I would like to thank Ashish for sharing his expertise with us. And of course, thank you everyone for being here and making this session a success. If you like today's webinar, I would request don't forget to check out our upcoming events on our LinkedIn page. We look forward to seeing you at our future sessions too. Until next time, have a fantastic evening. Thank you.